Welcome to Allplan Engineering QuickStart Lesson 10. In some situations, due to large openings in the walls, there is no room left for classical reinforcement. In such cases, one solution is to embed steel elements inside the concrete. In this lesson, you're going to learn how to model 3D steel columns with European profiles and also how to create their connections to the concrete slabs. You will now go to Open Project Specific Basis to activate the building structure. In this exercise, you will keep all concrete drawings in reference mode and choose a new drawing for the creation of the steel elements. You will go to the Modeling tab and choose Box Tool. The base plate will be created by clicking on two diagonally opposite points. The square will have the side of 15 centimeters and a thickness of 15 millimeters. To create the steel column, you will have to go to the Library, Default, Unfinished Structure, Steel, 3D Object, Rounded, Hollow Sections, Square, Hot Finished, and finally choose a profile of 80 by 80 with a thickness of 5 millimeters. In order to place it in the project, all you need to do is to drag and drop it in the middle of the base plate. To snap to the center, you will right-click in the isometric view on a corner, select Midpoint option, then left-click on the opposite one. Allplan allows the user to save any custom symbols that one might reuse in any project. You will go to the Library, Project, QuickStart Project Lesson 10, Steel Components, and drag and drop the M12 bolt. You will hover over the top left corner and input a delta X of 22 millimeters and delta Y of minus 22 millimeters. Then you can copy and mirror the object by snapping on the middle of the column and clicking on a left horizontal point. Choose both bolts by clicking them with the pressed Ctrl key and mirror them by the center of the base plate. In this example, it's required to model oversized holes to match a tolerance of 4 millimeters. You will create in the isometric view a cylinder with the center point on the column head, input a radius of 8 millimeters, and extrude downwards to exceed the thickness of the plate. This cylinder will then be copied to all other bolts. To create the openings, a Boolean tool will be used to subtract the cylinders from the base plate. You select first the main object you need to keep, and then you multi-select the objects that need to be removed. Now there are no more collisions between the bolts and the plate. Attributes are essential for any BIM project. You will right-click now on the base plate and select Modify Attribute, assign the steel quality, establish a unit type, and give the piece a proper name. The steel column we imported from the library already contained attributes. You will only need to assign a steel trade for it. You can now place the steel assembly created inside the concrete model. Having the concrete model in reference mode prevents changes being done to the concrete and also ensures a clear visualization. In elevation view, you can use the move function to position the base plate on top of the concrete slab. The top ending of the column will be extended using the Stretch Entities tool so that it will connect to the top slab. All that is left is to copy the adjusted assembly to the other concrete columns. Should you want now in the animation window to visualize only the steel structure while maintaining the concrete in the other views, you can easily do this. Allplan allows you to control the information you see in each view by isolating only the required drawings. To do this, you need to deactivate the concrete model from the drawings list corresponding to the animation window. In the animation, you see only the steel structure, while in the plane and elevation views, you see its positioning inside the concrete shell. In our next lesson, you will learn how to generate 3D reinforcement for slab based on finite element method results from SIA Engineer.